Please put your hands together in welcoming Eugene.
Thank you guys a lot. Thanks a lot for organizing and inviting me to talk. So, I'm Eugene, and as most of you, I'm a programmer, and I really love sound. And today I want to talk about complexity, how it arises, how when we approach it in the right way, we can find new things in things that we thought are well known to us. So when we can treat the problem as something building from blocks, then it's fine. We just do this, we deliver the result, and get next to the other project. That's fine. But there are different kinds of complexity, and as audio programmers, you very well know this. So when you have systems that have a lot of elements, a lot of feedbacks, or even just a single feedback, when emergent or chaotic behavior is not a bug, but a feature, and a desirable feature, then it gets really interesting and not really obvious how to start working with such systems. So, in such situations, sometimes analysis, like strict formal analysis, is no help. You can spend hours, you can read literature, you read formulas, okay, like you learned it, but it's still, like it doesn't click. But relaxing your mind into this problem sometimes does. And this is nothing like revolutionary or super new. Many experienced engineers in many areas of engineering know this, that sometimes it's about relaxing and meditating on the stuff that you're working on. And I'm sure that many of you, especially those of you who worked with feedback systems, will find a lot of things familiar here. So, the context. A couple of years ago, guys at Ando said, hey, Eugene, can we have shimmer? Okay, sure. So shimmer is a reverb plus mixed in pitch shifter, and it's all in a huge feedback loop. The only problem is that this is a huge real-time system running locally on a mobile device. How do you do that? So you read up a lot, and obviously you realize that all those advices with adding more mixing matrices doesn't work. You cannot allow yourself to do this. Adding more delay lines, yeah, it's cheap, but to an extent. You have to think about cache-friendly code and all that. So where do you start? I took shimmers and I started listening to them. Just what does it do? How does it shimmer? I tried to avoid giving names. I tried to avoid thinking like this is the thing that reverb does, this is the thing that pitch shifting does. Because really, if you just listen, do you really need a reverb? Perhaps you just need diffusion plus some spacey characteristics. What really does pitch shifting do in this context? What does it do harmonically? Do you need to preserve structure and all those questions? So when we label things, we do something like snapping to grid. But the grid works fine only for the known territory. And here, the thing that I forgot to mention, I had next to zero experience working with reverbs, developing reverbs and working with feedback networks. Like the large networks, of course. So I was just listening. Spoiler alert, the thing that I'm going to show you worked. I delivered the shimmer, guys were really happy with this, but that's what I did. Like what this is about. You can see 30 sliders. This is, by the way, not the end product, of course, but this is what I used. So this is an iPlug 2 prototype. I always use iPlug, just a great framework. And all the sliders have custom parameter mappings so that I don't spend time like precisely setting the values of this. I have custom mouse in, mouse out behaviors. I have everything here that allows me to spend as much time as possible only to observe the sound, only to quickly change the system and just write down something that I find. So, of course, like many of you know that there are mathematical tools that allow us to analyze complex systems, and they do it to a certain extent really well, like control theory, for example, or chaos theory. But they usually are, by their nature, reductionist anyway. Like, yeah, they can give us information about the general behavior of the system sometimes, or about a specific aspect of the system. But there's a fundamental problem with this. There is absolutely no bridge between the equation and what it means perceptually. Like, what do we really experience? All those like matrices of feedback values, what does it mean? How many delay lines do you need? Like, whatever. Experience gives us something very important. Like when we work a lot with some systems, we gain a lot of experience and something fundamental comes with it. It is intuition. So intuitions are non-verbal, almost embodied knowledge about what to do in certain situations, or how to behave with certain systems, to take a shortcut to the solution without spending painful hours trying to fix or to build something. We should not, and we cannot actually correctly verbalize intuitions because they are way below the language, the formal layer of our nervous system. But the thing that we must be able to do, we must be able to formulate the solution that these intuitions are pointing us toward. Okay. So we can gain these intuitions actually effectively, and this is why I built this UI. So how do we do this? Contemplative states help us a lot. Like when we spend prolonged, uninterrupted periods of time observing the system silently, playing with it, exercising just the minimal required amount of control, poking it in almost random fashion, listening to how the system reacts, and very importantly, listening to how we react to this. Then we try to gain these intuitions. And we, again, I must emphasize this, we should avoid giving names early. It might sound a little bit weird for some of you, but if you think about this just for a moment, what we do here, a very fundamental thing, we train our neural network, our nervous system, to gain feelings, to gain intuitions about the system that we're working with, lower than the formal and the language layer. This is not just, at some point, it's not just random poking the system. You, observing yourself, you will find that you are moving towards something, and this something yields results in the way. I've spent several days with this UI, actually about 3 days, and I should point out that this was only for the diffusion part, because you should also care about the natural feeling of the space that shimmer creates. You should care about the quality of pitch shifting, and there are a number of things that you should care about, and all of those are actually subject to such explorations. So these sliders that were on the UI, they are only for the diffusion. You may think about this like about working with clay or wood. If you haven't done this, you know this really well. To achieve fine artistic results, you have to let your hands do the thing. You have to let your hands feel the raw material that you're working with. You don't use any labels. And in this case, these delay lines and feedbacks are the raw material that I was working with. At some point, I noticed that, maybe it was the second day, that my mind was almost shape-shifting when I was trying to find the optimal set of the delay lines for this thing. I forgot to mention, like, I started with the figure eight design. Maybe many of you know what this is. Basically, you have one line of diffusers for left channel, one line for the right channel, and then negative cross feedback to the very beginning. That's it. Extremely simple scheme. So here I had 10 diffusers in left, 10 in right. And for both of them, I used parallel equal values of feedback. That's why I had a smaller amount of feedback sliders. So here you can see I just built a small demo with a more friendly UI. Things that I'm going to be talking about are still affecting all those feedback lines. But what I did here is I hid all the complex behaviors of feedbacks behind a specific nodes, so just I don't have to spend time like setting the specific values. Again, I'm going to show you only the diffusion, because this is actually pretty effective, and that's enough time to do this. We don't have to listen to really long tails, we don't need to have stereo sounds, we will just work on the diffusion properties, not even on the natural feel of the sound. You will see what I mean in a minute. You might notice that I have this main feedback slider on 0. So I will be feeding an impulse signal through the diffuser just once, and that's all, nothing else. Okay, so what can we do? We look at these 10 sliders, some values that I found somewhere online and started from them. Well, I have added a bit more delay lines. The original design, I think, had 6 per channel or something like this. The easiest thing that we can do, we can just scale them linear. That is how it sounds. So the full diffusion. And as we scale it, yeah, so it becomes more granular. At some point, when we scale them down, it becomes a clean delay. Just a clean delay. Okay, what if... So you play with this for some time. Okay, scaling is fairly simple, but what's the next step? Okay, we can try and scale only the shortest diffusers that will affect the transients. Maybe we want to diffuse the signal but keep some small details. So this is what this grind node does. It controls only how much the transients are affected. So again, the original, and then I simply make it granular. By the way, this is the usual sound that you get from feeding simple impulses to many popular shimmers. I just wanted to have the sound a smoother quality. That's why I added more smaller diffusers in the beginning. And in the middle, you have all the smooth transitions. Again, this nothing special, right? We worked on the first subset. What about the next? I think that you can guess it. If we scale the larger delay lines, we start to get echo. You might notice that these two sliders, by the way, have two ways of controlling, like negative and positive, but this is just because you can scale it a little bit differently, somewhat like tilting, and it gives different characters to the sound. So, where can we go next? Let's think. These feedbacks are pretty rich. So I have transients, I have a larger structure, and at this point I'm trying to feed different signals. So I'm showing you just the impulse, but you play with lots of different signals, with vocals, with guitar licks, with drumming, and you start to see cases where this simple diffusion network goes outside of the usual application range for shimmers. It does sound interesting, especially in larger feedback loops. Maybe we can be onto something if we continue to listen to this. So we could add more like fancy scaling, but that's not the point. Let's get back for a minute to the general scaling and think about what we really do here. So again, this is the full diffusion, and this is clean delay. What happens here really? So obviously in one case we have diffusion, in another we have like no diffusion, but do any of you notice some other property maybe that comes up when you listen to this? Just name a random sound property. Maybe something that has to do with the general dynamics. When does the onset start? So when we diffuse fully, we hear the sound immediately, although it's quiet, but it's still there. And when we scale the feedbacks linearly, we actually take 10-dimensional space, but we treat it as a one-dimensional. We just scale them on to 0 or to the initial values. That's boring. Perhaps there are trajectories, perhaps there are additional profiles that allow us to conserve diffusion and at some point change the way we perceive attack or maybe even release of the sound. Turns out, yes, there are such things, and I found them here. So the shape of the attack changes. Here it sounds almost like a pre-delay, and if I go the other way around, it sounds just like a huge reverb that hits immediately. Well, this is already interesting. Could I really land on this simply by analysis of the system? Possibly if I would have had knowledge of these systems, but again, this was my first test of this kind. And again, the fundamental problem stays the same. We don't have the bridge between the values and the experience. I have to be able to know that there is an ability to scale the attack of the signal, for example. So remember that these were only feedbacks. There are delay lengths, there are all other usual and unusual controls that you can come up with in the shimmer. And as a sound designer, I already see lots of additional approaches to using this shimmer outside of just adding spacey ambient stuff. Shimmer by its nature is actually a pretty meditative thing, and you can play with feedback loop and find the whole experiences as a sound designer and do interesting stuff with this. So I said that I delivered the shimmer. So as a final chord, I just want to show a quick demo of how it sounded. This is from inside of the handle engine, a simple frequency modulated oscillator and shimmer on top of it. That's it.